Hi, everyone. Welcome to our presentation of the abstract Screening Native Machine Learning Pipelines with ArgusEyes. I'm Sebastian, and this is joint work between our group at the University of Amsterdam and the DS3 lab at ETH Zurich. So our work is concerned with identifying what we call data-related correctness challenges in machine learning pipelines. So as you all know, machine learning is ubiquitous nowadays. Machine learning is used to automate decisions in all kinds of domains. But unfortunately, a lot of research only focuses on what we call the last mile of end-to-end machine learning, only model training and evaluation. That's what we study in academia, but once we bring machine learning models into real-world applications, into production, then there's actually a lot of issues that can occur that are connected to the actual machine learning pipeline, which consists of several data preparation stages that have to be executed in order to produce a machine learning model. So typically we consume data from many heterogeneous data sources. Then in a second step, we have to integrate and clean this data. We have to encode the data into features, maybe augment it. And only then do we get the actual training data or the serving data for the machine learning model. And during these data preparation steps, there are a lot of errors that can occur. So if we have data quality or labeling errors in the raw input data, they might propagate to the train and test data of the model. If experimentation is not done carefully, then there might be data leakage between the train and the test set. Many models require the actual features of the data to be normalized and don't work well if this is not the case. There might be what we call data representation bugs, or maybe unfortunately data of certain groups is filtered out during the data integration process. And there are common problems like data distribution shifts between the training and the test data. All of these issues are hard to catch, can lead to failures or biased predictions of the produced machine learning models. And that's why we are looking for an automated way to screen machine learning pipelines for such issues. And for this task, we implemented our ArgusEyes prototype. So ArgusEyes is a platform to automatically screen machine learning pipelines written in Python during continuous integration. So in order to do that, we model the machine learning pipelines as a data flow computation from multiple input relations in a star schema to matrix outputs. In the case of supervised learning, these matrix output would be the feature matrices for the train and test data and the matrix of predictions and labels, for example. Now, we execute this machine learning pipeline written in Python and instrument the code with our previous work, ML-inspect, to extract both the relational inputs of the pipeline. We capture the matrix outputs and materialize them. And we also compute the corresponding data provenance between the tuples of the input relations and the rows of the output matrices. By using ML-inspect, we can apply our platform on natively written pipelines that use declarative constructs from established libraries like pandas, sklearn, and Karlas. And then based on the relational inputs, matrix outputs, and provenance, we show how we can automatically screen for these correctness issues. Like we can detect data leakage, we can test for things like covariate shift. We can also automatically compute several fairness metrics for the predictions of the pipeline, and we can apply data debugging techniques such as Shapley value estimation. So I hope that's interesting for you, and feel free to have a look at our prototype, which is open source. Thank you.